So oxidation and reduction. We already know that oxidation. Well, before we go into too much detail about oxidation and reduction, most of us will probably know that oxidation is when something reacts with oxygen. But we're going to learn a new definition for it. So we've got potassium reacting with oxygen, producing potassium oxide. So potassium has been oxidized. That's not too hard to understand. If we draw a half equation, then we got potassium becomes K plus, because over here it's K plus. How did it do that? Well, it must have lost an electron. So that's the half equation. And we also said already that potassium has been oxidized. So the new definition of oxidation is oxidation is the loss of electrons. And there's a way to remember this: is oxidation is loss, and that is OIL, spells oil. So oxidation is loss of electrons. Now, if it went the other way around, if it went from potassium oxide back to potassium, we would say it's been reduced. So that's what reduced is like the opposite of oxidation. So in that case, it would have gained electrons. So we would say that a reduction is the gain of electron. Gain of electrons. So reduction is the word there, and so is the gain of electrons. So that spells rig, and together they spell oil rig. So that's your way of remembering that oxidation and reduction, the new definitions for oxidation and reduction, because you can actually have oxidation without oxygen. And if we look at this situation here, we've got potassium becoming potassium ion plus an electron, but also something's happened to the oxygen. Oxygen went from regular oxygen gas to an O2 minus ion, and two lots of them. And to do that, it must have gained 2 electrons. Now, if oxidation is loss of electrons, reduction is gain, then that means my oxygen has been reduced. This is kind of a weird idea, because that would suggest, because we originally think of reduction as the removal of oxygen, but now with our new definition, it's not necessarily that. We can have oxidation we can actually have the oxygen itself as being reduced. Now let's just do one more example here. Let's imagine we had sodium reacting with chlorine gas to produce sodium chloride. Whoops. We'll just balance that. And then look at what's actually happened to the sodium. So we've got neutral sodium on the left, and then that becomes sodium ion. So we use this. What's happened to it? We need to also add the electron. Its oxidation is loss. Well, it's lost an electron, so we can say that the sodium has been oxidized, even though it's not actually being collected any oxygen. So this is the new definition of oxidation, and there's it also comes back around to transition metals like Fe. So Fe So iron, an iron ion can be Fe2 plus, or it could be an Fe3 plus. And rather than call these charges now, we can call them oxidation states, because if this went to that and then produced with another electron, then despite the fact it's still just an ion, it's we can still say now that this ion has been oxidized. Maybe it went from just iron, regular iron, to iron 2 plus, and then to iron 3 plus. Then that would mean it was oxidized twice. So maybe it could be something like FeO plus O2. To be honest, I'm not really sure if this reaction could actually happen, but in theory, yeah, something like this. I don't know if this is going to work. Does that balance? No, it doesn't. Does it? That's complicated. I can't balance that on the video right now. But I'm under too much pressure. But the point is, if I could somehow balance that, you could see how we're increasing the oxidation state by adding more charge to it, by reducing the electrons.